heading in.
Oh.
All right, hey, everybody. Dagger team is here. We're live coding with you today. We're hoping to do a lot more of this live coding. And today we're going to dig into some of our LLM features that some folks have tried, but some folks haven't heard of yet. But here with me, I've got a distinguished crew of Dagger folks. I'm Jeremy on the ecosystem team, and I'll pass it around the room to Lev first.
Hello, I'm Lev. I'm a solutions engineer at Dagger, helping people get started and adopt Dagger. Kyle?
Yo, I'm Kyle. You've seen me on the YouTubes before. There's my name.
It was on the other side, actually.
You, Jason?
It was.
Yeah, it was. Point the other side. Other
is it?
hand.
Oh no.
Yeah, there it is. There it is. Yes. Mine's here. Cool.
Nope. Wrong side.
No.
Really? Oh, there you go.
It's on one side of the screen.
I think
That's the
everything's
same trap
flipped.
I did.
I think
Yeah.
everything's flipped.
Hold on.
And
There's
then
a setting for that. There we go.
Nice. Jason, how about you?
Hi, I'm Jason. I'm on the ecosystem team as well.
Sweet. All right. So, and anyone you're welcome, obviously, to join. We should be streaming to LinkedIn, YouTube, and X/Twitter. And so if you're seeing us there, if you've stumbled upon our stream, our humble stream, please engage, chat with us, ask us questions if you see something that you don't understand and you want to know more about. And we hope to do more and more of these. So hopefully it'll be a regular thing and you'll come back and see cool content all the time. Who wants to drive from our side? I think we were going to dig into the docs and like I say, fire up some stuff with this LLM.
I'm ready
feature.
to drive if you'll allow me.
Absolutely. It would be an honor and a pleasure. Let's add you up there.
So I had my code pulled up that I did in the last community call because it already takes advantage of some of the LLM stuff. But I wonder if we should just like start from scratch and make something real quick.
Yeah, I think we should take it from the top.
Take it from the very top. Okay, so I'm just going to exit there and get into our docs. So we do have a really great quick start for building an AI agent. And it's all built on the same primitives that we have for building all other types of pipelines. We just have these two new primitives. One is LLM, and two is this concept of an environment, which we'll dive into here in a second. But I think we maybe start by walking through the quick start. And which language should we use? Which language are we using today?
It's Python it up.
Really?
Yeah, it's extra challenge.
Mode. Yeah.
Okay. All right. Well, in that case, I'm going to zoom in a little bit before Jeremy yells at me. Also, every time I say I'm going to zoom in, I always have to say before Jeremy yells at me. So I'm just going to go into a blank directory. I'll make a new. Oops. Yeah. So I'll make a new directory just for this. We'll call it live stream. Right. And then it's Dagger init. Oops, sorry. Dagger init SDK. Sorry, the copy and paste is really weird for some reason. But Dagger init SDK is Python, and the name we'll call it coding agent just to keep it consistent with the live stream or with the docs. So what this will do is it'll generate a new Dagger module with all of our kind of pre-baked boilerplate code. And now if we open up a Dagger shell, that'll load in that module that I just made. And if I say, give me some help, we notice that there's these two functions that appeared, container echo, grepter. Let's look at the code maybe. So yeah, I trust the authors. This is like the boilerplate of making a new Dagger module. And it's different for every language. There's a slightly different boilerplate depending on which language you choose. But all the most important code in the Python one is inside of the source directory under main.py. So here is where we're defining these Dagger functions. And a Dagger function is a regular Python function or a Go function or whatever the case might be, with the difference being that it's going to run inside of a container when it executes, and it's going to return some type that may be a Dagger native type. Now, I'm noticing out of the gate, one thing is I don't have any type hints.
Yeah, should we
So
fix that?
we should fix that. And luckily, I think I know exactly how to fix it. If I open this with UV, if I just like wrap VS Code in UV, I think it'll do the right thing.
Yeah, you might have to UV run code.
Thank you. UV run code. That'll go wrap up all of my lovely things into a I guess a UV workspace or UV environment and give me what I need, except it didn't really work, unfortunately.
You might have to wake up VS Code. Sometimes I haven't used VS Code in a bit, but you can point at which virtual environment to use. It's basically it created, you can see on the file bar, it created a .vm in your directory.
Oh yeah.
And so you want to basically tell your editor to use that. And if you're using Zed, I could tell you how to do that, but I've forgotten. No. No, I've forgotten the magic VS Code way of doing that.
Oh,
yeah, I think you're on the right path, though.
Yeah, I think this will work. All right, so whoever said we should start with this SDK, I'm gonna blame you.
He did say hard mode, so you know.
No, this can't be that bad. Now, do I need like the Python extension? Do I have that? Is that like a thing?
I think you're
Let me try. Let me start there.
Yeah.
Let me just start there just for fun, real quick.
Did you follow the IDE instructions?
Yeah, let's go do that. Actually, you're right. All right. So
the search bar will help you here.
IDE integration for Python. Dagger develop UV run code. That's it. That says that's all that it should be.
Did you Dagger develop?
Assuming that Python extensions are installed. So that's my issue. Is I didn't have that installed.
Did you Dagger develop?
Let me try that real quick. Yeah.
That'll generate the code gen.
Yep.
I mean, we should.
Yeah, and since it was just initted, it should be there. But yeah, if you do
run.
Yeah, in code, if you do like Shift Command P, I guess that's how you can select your VM. There it is in the bottom right.
Oh yeah, it's got it.
Perfect. Yeah, and I have my type hints now. So we're in business. So all you gotta do is read the documentation, which is what I should always remember to do. And in this case, the issue was I didn't have Python extensions installed. That's going to be required for VS Code for this to work out of the box. But just to recap, we did Dagger init, and then we did Dagger develop, and then we ran UV run code, and that opened up my sample project. It opened up in VS Code, and it gave me all these type hints. So now, as I'm writing my code, I'm going to get all of these Dagger types just automatically loaded into my environment, so I can easily work with them and create new ones. Now, the basic functions that we create when you initialize a new module are container echo. It's just like it just returns a string of whatever you put it in, or grepter, where you give it a directory and it returns lines that match some sort of pattern. These are like rudimentary samples. Maybe we'll get rid of them, but let's just keep going to quick start and see what it asks us to do next. Yeah, so we made a new module.
One other thing. I'm going to be like that guy occasionally. But like one other thing, another goal for this as we're going through this is like to obviously to impart knowledge for folks that are getting started, and if it's helpful, and for us to also run through our own stuff, dog through our own onboarding, and see what, if there's stuff that can be improved. One thing I was just noticing there is we had to know to go look for the IDE docs. Yep. And then I was just looking to see if there was a link to it from the quick start, and there wasn't. So I'm thinking that's something we could do right now, is make PR for putting that in, as like, because we know
that's a great point.
Have the best experience if you have your IDE hooked up. Really.
Yeah, that's a good point. And in fact, like I think someone that may be new to Dagger may not even know how great the type hints are, so they wouldn't have even noticed that there was a problem.
Yeah.
Maybe ever. But then you miss out on this like rich DX So yeah, it's a tricky one, right, to get right. But I agree with you. I think
I'll do
that,
it right now. I'll do it on the side. I think we should just keep fixing stuff as we find it.
Yeah, let's do it.
Okay.
Okay. Before I keep going to the quick start, let's just go back and see what happens. So in Dagger's shell, like I said, it's loading these functions. So basically, whatever functions exist in your module, they get loaded into the shell. So I can go through and call them now. So for example, I can just call container echo, and it'll probably not work because it says requires one positional argument. It needs some sort of string. So maybe I'll just say hello. And now it's basically executing that function, passing in the argument hello, and it returned a container. Cryptic, right? What can I do with a container? It turns out I can do a lot. So what just happened was whenever you return some sort of type from the shell, if you're unsure what to do next, you can always pipe in this help function, this built-in help function, and it'll tell you all the things that you can do from that point on. So in this case, it returned a container, and I can run all these additional built-in functions from the container. In my case, all I really want to see is the echo. So I think I can just grab the standard out. So let's try that. Boom. Hello.
Whoa.
So yeah, that's the basic idea. So as we continue to work through this, we're going to write our own functions. They're going to return specific types, and we're going to be able to kind of continue to compose those types into more complex functions and achieve whatever goal we have. So let's go back to the quick start and keep going. So we've made it through generating our module. It's in Python. I can call Dagger functions, which is another way of a different way of using shell. In fact, I wonder, like, should we not introduce shell here, or or should we? Speaking of the kind of like walking through the docs, Jeremy.
Yeah, I think we go into it or a bit later on.
Oh, we do. Okay.
And one of the reasons for that is I guess you might show it off soon, where if you go make code changes now and you're in shell, you might not see those code changes happening, right? So you don't want to enter shell too early.
That's right. That's a good point. Yep. Okay. Yeah. So everything we just did with the shell and help and all that stuff, you can also get information about this specific module by calling Dagger functions. So that's what we did here, and it returns a list of the functions, same exact functions that we just saw. And you can call these outside of the shell too. Just as an example, I can say Dagger call container echo. I forget the syntax. Oh, it's a string arg. Okay. So then I'll say string arg. Hello. Once again, it returns a container. So in order to get the standard out, back out, do I just say this?
Yeah.
Boom. Hello. So that's the main idea. Notice how this is cached, which is nice. So I get it back. I get it right back right away. So this is like a slightly different way to interact with Dagger, but the shell you'll see is just much more pleasant overall, and also allows you to do things interactively without having to wait for this loop to run each time. So we've made our first module. Great. Now we want to make an agent. So we're going to go back to that place where all the code was, with all the boilerplate code, and we're going to replace it with this example instead. So I'm just going to go ahead and copy and paste it directly, and then we'll inspect the code once we're inside. So here's my new Dagger function with all the code replaced. But the main thing that's changed is I replaced my container echo function with a new function called go_program. And this function accepts an assignment as a string argument. So in the same way that we accepted a string arg for the container echo function, here we're accepting a string argument into this go_programmer function. And similarly, it returns a container type. So it accepts a string and returns a container. Inside, it's doing a lot. So we can walk through the code here, I guess. I'm assuming the quick start also talks about this, but I wonder if it's easier just to go through like this way. But the main ideas behind this agent that we're building, a Go programmer agent, is we're giving it a sandbox execution environment in which it can have access to various tools that it can call to achieve its task. And I think the idea behind this is if you give an LLM an access to a VM, it'll it can figure out how to do stuff. Like it's really good at reading man pages and running Unix commands and all that kind of stuff. So it'll figure out stuff to do, but it might be too open-ended, right? Or it might have too many permissions, or it might do very, very different things each time you ask it to do something. If you just give this open-ended VM with all the possibilities in the world. So instead of giving it this open-ended environment, it would be better to give it a sandboxed environment that not only is sandboxed from a security perspective, where it doesn't have access to everything and every single environment and every single thing that exists in your VM, but it's also sandboxed from the point of view of what it can do, right? So rather than being able to just run any arbitrary Unix command or install any arbitrary software or connect to any arbitrary service, you can give it a much more constrained environment in order for it to complete its work. And we find that giving it that constraint allows the LLM to more consistently use whatever tools you give it. So that's what's happening here. So in this function, I'm creating a new environment. This is using a specific environments API that we've created. And these are all kind of first-class Dagger types. So the first thing I'm doing is I'm grabbing this DAG. This DAG object is basically like a client to the Dagger engine. So think about it. There's this engine that's running. It's a container runtime. It's able to run whatever instructions you give it, and it has some kind of built-in types. And this DAG is just a client to that engine. And we're making a new environment. And inside of that environment, we're giving it an input. So inputs and outputs is similar to how you think about all other functions, right? You have a function that does something, it has inputs and it has outputs. So in this case, we're giving it an input of the assignment. We're giving it an input of a container. That's the place where it's going to do its work. And then we're going to give an output of container. So basically, this is just describing the environment as being a container, basically, that has a string input. We're building this container on the fly. In this case, we're calling it builder. We're basically setting a variable called builder, and we're creating a new container on the fly using the built-in Dagger API. So here I'm saying dag container from Golang with a new work directory called app or /app. But just like we're passing assignment into this function here, we could have passed a container as an argument as well.
Wait, I have a question here.
Yeah, please.
Okay. So I mean, when we're saying a container input, which we're passing this particular one that we're building on the fly there, that Golang container with the worker. So we're going to give that to the LLM, and it's going to be able to there'll be a certain set of functions that containers have, right? That'll be exposed. So that's we're giving an object, and that object has functions. All those are tools, right? Once those are all tools, and we can give it multiple inputs, and we can ask for outputs.
Yeah, exactly.
The one thing I was a little bit, just kind of a structural thing, and I know we're going to get to it in a minute, but while I'm thinking about it, that string input idea where we have the assignment there as a string, so a scalar kind of just going in, we then and we're going to, spoiler alert, we're going to reference this assignment a little later in the prompt. But in the spirit of the idea of having an environment for having an LLM that you've chosen, local, cloud, whatever, having an environment you've prepared with some objects that have some functions, some state and some functions, basically. And then the third thing being the prompts that you use. Mm-hmm. It felt a little bit to me by us putting this string here and then referencing it later in the with prompt down below, it felt a little why not just do a string replace on the prompt string down below here, why inject it in as an assignment in the environment? It felt a little bit like crossing a barrier of a separation between prompt and environment a little. And that's something I wanted to throw out there. I'm guessing that maybe Kyle, you've thought about it one way or the other.
Yeah.
I'd love to, as we get to this point here, it's been nagging me and I wanted to raise it.
Yeah, for sure. So the fact that it's referenced later on in the prompts where we say, if you go to the end of the prompt below, your assignment is $ assignment. That's a bit of a Band-Aid as we kind of get things working better in the internals of how LLMs are interacting with their environments. The goal is that part isn't referenced in your additional prompt at all, because if you look at the environments, the descriptions, you're actually building up your prompt as you go, right? So you can see the description of that string input, the assignment to complete. That's prompting. That's saying this object I've given to you, whether it's a string or a container, this is what it is, and this is how you can use it. So same with the container input, you say this is what you're going to use to build Go code, which is part of the task that the agent was going to complete. So the idea is that your additional prompting that might happen later on is more about the more general, like
more system prompt kind of stuff
more,
of like,
more of a
this is your role, this is your, yeah. Okay.
So yeah, right now the fact that it's in both places is a bit of a mandate that hopefully won't be necessary soon.
Okay. That's interesting.
And to add on to that, actually, to add a bit more, if it really depends what model you're using for what the prompt looks like. And so if you're using something like for GPT 4.1, which I was testing earlier today, you actually don't need to reference it in the prompt below at all. You can just say you're an expert Go programmer. And let me see if I can remember what else the prompt looked like. But it's like the prompt that's in that quick start is meant to be like kind of a general purpose prompt that can work with a lot of different models. But the reality is that most models kind of have their own way of prompting successfully. And when you build your own production agent, you'll have a prompt that's tailored specifically to the model that you're using.
Got it. So that's that whole notion of like evals, right? Like people are like, they're kind of going through that combinatoric exercise of like, what if I alter the prompts in these ways, or I alter the environment in these ways, or choose different models at different sizes and quantizations and whatever, and from different providers. And, where do I find the sweet spot of something that works great for my application and consistently?
Yeah, exactly. So I found, oh yeah, go ahead.
Sorry. I'll say I found this actually bit me earlier this morning and last night, where I was posting. I wasn't using that variable in the prompt, and it kept just stalling. You just say, "Okay, give me your question. Give me your question." And I actually tried GPT 4.1 and it did the same thing. So I'll have to try that again. But yeah, using the variable like seems to kind of really help it.
That's cool. I was going to throw out one more thing too, just while we're at a break for a second. We had Sebastian, who's watching us here right now, had a question we can also like keep in mind. Highlight. Nice. Yeah, talking about the Dagger cache system. As we know, or if you haven't tried Dagger before, Dagger caches everything by default, and it's this content addressed caching, so that like if the same kind of stuff has happened, the same inputs to the system, we can cache values and give you that back without having to recompute it. And so you think you will see this ability after we run some things where having the system in one state and getting an output will actually be cached and be retrievable and then like chainable onto another operation. But there's also this idea of memory for an agent being something a long-lived thing, an artifact unto itself, which is interesting. And I don't know, it kind of feels a little bit almost to me like, like where do you put that stuff? Like, where are places you could keep memory? Could you you could store it in one of our cache volumes and rehydrate it. You could put memory into a container, an OCI image, and throw it up somewhere and pull it back. You could in a file. I don't know, be like an interesting interesting thought is using our cache system.
Yeah, absolutely.
Thanks, Sebastian.
Yeah, thanks for that question. So we have our environment, and next we're going to ask it to do some work, basically. So remember, we're working on a function called go program, so it should be able to do some programming. So this is the actual work of doing that programming, and in this case, this is returning. I guess this is an LLM type, right?
Yep.
Yeah. So this is an LLM type. So essentially, it's taking back to that DAG client. It's calling this other LLM function. So this is a separate. So we saw the end for the environment primitive. This is the other primitive that's related to agents, which is the LLM primitive. And an LLM primitive basically allows you to initialize a large language model, and it allows you to parameterize it. So by default, it's going to use environment variables that exist within wherever you're running the Dagger CLI. But you can also change the model kind of on the fly programmatically if you want to. Which models are we supporting at the moment?
In terms of model providers, so you can use OpenAI, Google Gemini, any Anthropic models, anything that supports tool calling on Ollama,
Nice.
Docker Model Runner, Azure Cognitive Services.
Wow. Can I run it? Can I run like a thing locally too?
You could, yeah. So with Docker Model Runner or Ollama, you can run models on your machine and point at them with Dagger.
But I need like a GPU and stuff?
No, if you're on Mac, like Apple Silicon,
that works.
It works fine, yep.
Got that unified memory.
Exactly. And Ollama itself will run on CPU. It's fine. Nice. Like if you're running
really?
actions or whatever. Yeah, it's slower, but
everybody wave Tony. Hey Tony.
Wait, hey Tony. What are we talking about slower? Or like, have you tried this? I'm curious.
Yeah. So Ollama, you can run things GPU-less. Wow. It runs against your CPU. It just if you're using like a big model, you might wait all day for it to run. It's significantly slower. Yeah. But it works.
That's cool. But yeah, awesome. Thank you. So here, we're initializing a new LLM type, and we're providing it an environment. So we're basically giving it an environment to the LLM, and then
the one we defined above, right? The one we just
exactly.
Defined
so
above.
Here, we're passing the environment that we created earlier into this LLM, and we're giving it a prompt. And the prompt is just giving additional context to the LLM. And here we have this prompt that's just an inline string. You can also have the prompt be like a prompt file if you want to have like a much longer prompt where you massage it a little bit more. That's fine too. But here our prompt is saying, hey, you're an expert Go programmer. You have an assignment to create a Go program. Use the files or create the files in a directory called from builder. And this is where we were talking about those environment variables, I guess. That's an overloaded term, right? But my Dagger environment has these variables, right? So the name, value, description. So I'm using the builder, the name of the builder as a container input. So it's saying, hey, use the files or create the files in the default directory in the builder. Always build the code. Don't stop until you're done. And then your assignment is given to you as this variable. And again,
I'm actually surprised at how well, like, because I've done this like interactive mode in the shell too, and how well that idea of like $, the name of the object in the environment works. It's like pretty cool. You can do it. And internally, it's like doing stuff like calling that like container 1 or container 2 as it's building them, but like it's that mapping. And I was like, it's pretty
I love it, honestly. Like, it reminds me of like back in the day, like in school, like a lot of times you get these pseudocode assignments where it was like, write some pseudocode to do this thing, and then later on you'll implement it as real code. But now it feels like you can just write pseudocode and like it'll just do it. It'll just work.
Yeah.
So like, it was always my dream, as a lazy student, to just like have my pseudocode work, and now my dream is coming true. So ultimately, we give it a prompt, we give it the environment, and then we return the environment output. Remember, the output we said was a container output. So we're returning container
completed.
Yeah, exactly. So the container output with the name completed. So this is going to be an actual container type. and then as container. So just kind of clarifying that this is a type that we expect to come back, and recall that this function itself is typed as well. It's typed to return a Dagger container type. Now, yeah, so this is like Python does not require you to use types in principle, but writing Dagger functions with Python does require you to use these types because you need to, because Dagger itself is a type system. So that's what's happening here. So if you're not familiar, I think this is using isn't there like a specific library or something, or a specific feature of Python that this is taking advantage of? I don't remember what it's called. It doesn't really matter, but yeah, typed Python is what's happening here. Okay, so that's it. So 40 lines. Yeah, go ahead.
Maybe it's worth talking about why you're returning container versus a string, or the different types of things you could return from the environment.
Yeah. Well, I think in general, in like general Dagger philosophy outside of LLMs, I think that there's a bunch of core primitive types, right? And the main ones that you work with on a regular basis are containers, directories, and files. Because if you think about like what you're doing when you're running a CI build, is you're usually like taking a Git repo, which is a directory, doing stuff inside of it, and then returning like an exit, a string output and an exit code, or maybe you're returning a jar file that you're going to upload to JFrog, or maybe you're returning a container that you're going to publish to a registry. So those are the core types that you normally work with as a part of any kind of CI build. And in Dagger, you have these core types as well, right? It's the container type, the directory type, the file type. It is helpful sometimes to write functions that return a very specific output, like string or file. But it's also limiting because you can always get a file out of a container, but you can't get the container out of the file, right? So as a general rule, especially when you're getting started, we recommend using a more abstract type like container rather than a more specific type like file, so that you can experiment more and do a lot of different things with that more abstract type than you could if you just were working with a file. So that's my general reason for why I'm returning a container. But if anybody has a different take on it, I'd love to hear it too.
Yeah, that's exactly why I do that in general, is that you can then use the Dagger CLI or Dagger shell to take that returned artifact and do whatever the next steps are, whether they're inspecting it or adding some more things or publishing it to some storage. And in this case, when we're actually having an LLM write a program in this container, we actually want to get dropped into a place where we can run that code or look at that code and do all the things inside of a container.
Exactly.
Yeah. Just so you know, we are inspiring FOMO around the world here.
Okay.
But now I've got FOMO because like Solomon wishes he was with us, but he's working on his own prototype, so I don't even know how to feel about this. But we did get another question intervening. Okay. So because we're talking about all these amazing types of artifacts that are floating around, Patrick said, "Hey," and he followed up saying, feed the LLM image, but the idea is like, could we be going multimodal? What's the limit? What would prevent us from, working with image type files, for example? Has anybody tried it? Anything like that?
So as far as I know, right now we don't support like file attachments in the API call, but I don't think there's anything specifically restricting us from supporting that. As far as I know.
I see. But when you say multimodal, you mean the multiple types of data, not multimodal.
Right.
I heard. Okay, got it.
MODAL. Yeah.
Got it. Yeah. Okay.
Because like I've noticed this. I actually noticed this before, where there's an interesting thing where, Dagger files, obviously it could be any file, but yeah, there's like that, a lot of times we're doing things with files in our very like command line, plain text worldview. We're often finding ourselves going, oh, just give me the standard out, or just give me the contents of this file. And I, spray out a string or something like that, which is awesome, unless it's a binary file, right? And I guess even out there in the world of like MCP and stuff, you see people base 64 encoding binary files a lot. going in and out of models that way. But yeah, there is this kind of like, it's interesting working with the binary file is something, something
Jeremy,
amazing.
Go ahead, Kyle.
Yeah, just like to summarize like the technical side of it, what Dagger does right now is specifically interacts with LLMs via tool calling. And so we take all these objects within Dagger and expose them with our internal MCP implementation to expose every part of that object as tool calling. Now, attaching files and uploading things to the model is a separate type. It's a different type of, or it's a different way to interact with models, basically. And so it's not what we've implemented, but maybe we could, right? Like Solomon said here.
Oh, nice. Yeah.
I want
Well, one of the things too that Jeremy, you were mentioning earlier this week is that you wanted to build a graph, and you're talking about just using a module and publishing a module that just takes those as arguments and returns that file type, right? So you could just use another module that maybe you don't need to feed that to the LLM, but if you need to get the response and put it in a graph format, you could just have a module.
Like to draw a chart. Yeah, to draw like a visual. Yeah. Because we do graphs all day long.
All day long.
Yep. All dags. But yeah, if like Patrick mentioned, if you wanted to, if you had something that generated an image and you needed to give that to an LLM somehow to evaluate it, you would need to be able to upload that image. So yeah.
Yep.
Yeah.
And then I haven't tried this, just a crazy idea, but like once you're inside of this thing, couldn't you give it a tool that knows how to do that? Like, couldn't you write a module that separately makes a call?
Sure, yeah. If you wanted to implement the image to text or whatever other capabilities in a module and specifically use like the OpenAI SDK in a module, you could do that for sure.
Interesting.
But it'd be cooler if you could just do it through the Dagger API.
I agree wholeheartedly. I think it would be. I mean, I could see that as a logical next abstraction to be multimodal types and things of that nature. That seems just like a logical thing to do. But I think it also worth highlighting that like Dagger is not so rigid, right? Like it's a very like this is just a Python program. So any library that exists in Python, I could technically call and use as a part of my function. And there are caveats in just how it works behind the scenes and like whether or not things are running in the like using Dagger types, all this other stuff. There's a bunch of there's a bunch of stuff you can dive into and learn more about. But at a fundamental level, like the beauty of Dagger is that it is just a program. It's just a regular Python program, a Go program, etc. So you have the entire world of libraries available to you if you choose to use them. And I think you can combine Dagger with a lot of other tools in that way, in very interesting ways, to where you can use Dagger for the areas where it shines, which is sandboxing and strict typing, all that kind of stuff, and then maybe you can use other tools to get the nitty gritty work done under the hood without re-implementing it yourself from scratch.
Yeah, and on the A2A side,
I know because we invoked MCP and so A2A appeared.
Oh yeah, so for sure, yeah. It's kind of cool. So like with Dagger, all these agents are just functions of objects. So you can actually connect, like you can give all of these other agents to an LLM as inputs to its environment, and it can choose what's called when. So it's kind of similar to the A2A design, but I think we will figure out like how Dagger fits with actual A2A sometime soon.
I'm looking forward to seeing that in a future live stream.
Sweet.
Let's keep going, shall we?
Yeah.
So at this point, I think we've walked through all the basics. Now it's time to run the agent, and this is where we're going back to this shell. So I jumped the gun a little bit. Sorry about that. So now that we've changed all the code, I'm going to restart the shell. Just call Dagger inside the same directory. It'll reload the shell, recompile all the right types. The first run might take a little bit of time, but all subsequent calls will be much faster. And
hashtag caching. What's it?
I can start by saying getting help on the Go program. So Go program, again, remember, this is the function that we just wrote. And by the way, if you call help, you'll see all the functions and notice how previously we saw echo and grepdir. and now we have this Go program. So basically, like there's a one-to-one relationship between the functions in your program and what shows up in the Dagger shell, and all these other things are just built-in capabilities of Dagger that just exist out of the box. And this is my custom program. So if I say help Go program, this says, hey, this is a Go program. It accepts an assignment as a string, and it returns a container. Okay, great. And then it's saying make sure that your LLM provider is properly configured. So if I call, just like I can call my custom function in the shell, I can also call any built-in functions in the shell. LLM is a built-in function. So if I call it, it says LLM. And if I pipe model, it'll tell me that it's using currently Claude 3.5 Sonnet. Now, the reason why it's using Claude 3.5 Sonnet is because I have my Anthropic key set in my environment where the Dagger shell is executed. On that note, was that a prerequisite already that we just skipped over? That I skipped over?
It was, yeah.
Oh, I see. Yeah, sorry. This is a very important part. I'm so sorry. You must configure the LLM endpoint. And by the way, Jeremy, I would really love to see like the example for like OpenAI Anthropic or whatever right here, and Gemini right here, instead of clicking out, because otherwise it becomes too easy to like, oh, do I need that? I don't know, right? So my general preference when I'm reading docs is to have the things that I must do in line, and then extra information somewhere else, right? So that's just my 2 cents that's there. Great. But if anyways, this is a required step, and I go there and it tells you for whatever LLM you happen to be using, this is how you set it up. So in my computer, I have Anthropic API, and I don't have the model set, so it defaults to Claude 3.5 Sonnet. If you're using OpenAI, this is what you do, etc. We have more and more coming all the time. So if your favorite model provider is missing, please let us know about it. We'd love to hear and get support for that going. Okay, so I have.
There you go. That's another note. It's another to do.
Let's do it.
Or pull request accepted, one or the other. Either way.
Yeah, sounds good. I'll send a PR. Okay, so call the Dagger function. So now we're finally ready to go and like call our agent. So I'm gonna say write a curl clone. So it just says like curl, the HTTP client, do that for me. So when you do that, now it's invoking that function inside of a Dagger engine. And in my case, the Dagger engine is running locally on my laptop, but I could also have it point to a remote service. I can run it on Kubernetes. I can run it on a beefy server somewhere. The sky's the limit. Basically, anywhere where you can run a container, you can run a Dagger engine. And in my TUI, I'm going to get the output of everything that's happening within the program. And you'll see that, here is my prompt. Here's the AI thinking about what it's going to do next. We can continue to observe this inside of the TUI, but you can also see this running inside of Dagger Cloud. Dagger Cloud is an observability product that allows you to get tracing of your pipelines, and that includes both CI pipelines and also agent pipelines. So there's a nice little shortcut from the TUI. If you exit input mode and press W, it will just open up this trace in the web, and you'll see that our entire session is here. So earlier we were getting help to Go program, we were checking our model. So everything we did was captured in this session and sent to Dagger Cloud. And now I can zoom in, of course, and I can see basically the same stuff that I saw in the TUI, but the difference is it's a little bit cleaner, and I can share this link with my team. So if I need help later on, if my agent's not doing the right thing and I'm stumped, I can share this link with Kyle or Jeremy or Jason or whoever, and they can investigate this themselves and give me some advice. So that's the main idea here. And by the way, this is there is a single user free tier of this, so you can sign up and use it if you so choose. Now, the main benefit here is what I'm able to understand is not just what did I tell the agent to do, but also what is the agent actually doing. One thing you'll notice if you start playing around with models, especially with tool calling, is oftentimes they'll just like gaslight you, just lie to you constantly, and say, if you say make me a curl clone, sometimes it will, and sometimes it'll like say it did, and and it didn't actually do anything at all. So being able to actually understand all the things that happened is incredibly powerful. as you're developing your agents, and you kind of just get that out of the box here with Dagger Cloud. So in this case, I gave it a prompt and it started to go to work. So first, it checked the assignment. You can see it was calling, it was referencing variables that we included in the environment. It selected a container, and then it started to get to work. So containers have built-in functions such as with new file. So if you recall, earlier, we got help for container. We saw all these different functions. As Jeremy pointed out earlier, like what's actually happening here, sorry, maybe it was Kyle. One of either Jeremy or Kyle said, what's happening here is we are giving the Dagger API as a tool to the LLM, right? So in this case, the container type has all these other functions built into it, and now the LLM can use those functions to achieve its goal. And again, there's the built-in functions, and then there's the functions that I've created myself. And that's like really the magic here, is it turns any Dagger module and Dagger itself into a tool that the LLM can use to achieve its work. So here, it took the container and it called the with new file function. We didn't tell it to do that. We asked it to write some code for us, and it figured out that, I probably need to put that code in a file somewhere. So I'm going to use this built-in function. And next, it built it. It called build. It called with exec. It didn't work. It was like, we need a Go module. Sorry. So then I did Go mod init. And frankly, like I love watching this because it's exactly what I would do probably as a new Go programmer. Is like, I know what to do. Start to write some code, and then it doesn't work, and then I go read the docs finally, just like what happened here earlier, right? And eventually I'll get to the right answer. So you can investigate every step of the way what it's trying to do, and then at the end, it finally built successfully after doing a bunch of different work, and it gives me some instructions on how to use it, which is fantastic, and it returns the container as I asked it to with my curl clone inside of it. So that's fascinating. But what does that actually mean? Earlier someone asked, I think Jason asked, why are you using a container? I think the number one reason why is because with a container, I can, we saw earlier, get the standard out. I can call additional functions, but I can also just open up a shell inside of it. I can get a terminal inside of a container. So if I just call that exact same function that I just did and say terminal, it'll pop me into a shell. Notice how it didn't rerun the entire.
Yeah, it was fast.
The entire
cache.
Yeah, it didn't rerun my prompt. It just took my container that I just returned and changed terminal on it. And because nothing else changed, it popped me right back into what it just did. So inside of this directory, I'll now see that there's a main.go. This is what the LLM generated. Oops, sorry. This is the Go file for curl. And it even tried to build it. So I'm assuming this is a binary of Go of the curl clone. So I can call it. It's like, sorry, your error, like URL is required. So it even has error checking and stuff built into it. So finally, if I call I need a
HTTPS, I think, or something you need. Yeah.
The safety protocol first. Okay. Hello.com. It then says hello. So it is a curl clone. It does actually curl websites and HTTP endpoints. So that's fantastic. So now I have my proof that this worked. Great. But I don't so how do I use this? Like, what if I want to ship this to production? What do I do, right? So like, I don't really need this container anymore. I don't need the directory of the app directory. All I really need is this binary. This is gonna break, right? Because I'm gonna try to run it on my Mac. But let's see.
Do it. Or you want the source code, or I guess whatever you want. What do you want?
I want the file. I want the file. So I can just similarly, we can get the terminal. We can get standard out. Can we get files out? Probably, right?
As file.
Retrieve a file. Okay, great. How does that work? Path and some options. Okay, so I know that the file exists at app/go.
Main.go.
What was it?
Main.go or go curl?
No. Go curl. Okay. So this is the file. Okay, so what is that? Like, what can I do with the file? Oh, I can see the contents.
No.
I would not do that.
But I can also export it, right? I can export the
Binary,
file and send it out. So great. So let me just do that. And I'll just send it here. I'll send it to my local directory. And this is going back to Lev, Laz, Livestream, Go Curl. So
I
this
just
is where
saw
I
your Dagger cloud, like your telemetry just updated too.
Yeah. So every time I do anything, it keeps going because the session is still alive in the shell. So it's just sending telemetry out. Okay, so now in this directory, I have Go Curl. Now I think it's not going to work because it was compiled on Linux container and I'm on Mac. But just for fun, it's not going to work. But I don't want to get too crazy, but you could probably tell it to, hey, make me a multi-arch Go. You know what? Like, why not? Can we try it? Are you guys down?
Let's do it.
Let's do it.
Yeah, tell it to compile it for Darwin.
Oh, okay.
Darwin ARM64, because sometimes it goes AMD 64.
Oh, yeah.
Okay.
Yeah. It should probably figure that out by default, but we'll see.
All right, we'll see. All right,
because I've seen it oftentimes try and pull containers at AMD 64 for some reason, and etc. So
I mean, we are now officially off script, off book.
Yeah.
So we
completed the quick start.
We have achieved the quick start. Yes.
I think you've broken the LLM.
Wait, what happened?
Cloud says it's done.
You're overloaded.
So do we have another token?
Yeah, you burned through that token, man.
Really? Oh, it's overloaded.
Yeah, it's
I
overloaded.
see.
Yeah.
It's either overloaded or it's.
Try again. No, once it's overloaded, it actually gets cached that way. So
but you can change your prompt by a character or something.
Yeah, put a period.
Oh, right.
Yeah,
Sorry.
Restarting the shell is good too if it's faster.
Yeah, it's my usual.
Why is it so slow?
My usual go-to.
It'll save your work at least there. Yeah, save the prompt, the assignment.
Right. Boom. Yeah, but we're officially off book now. Like this is now beyond the quick start. So we finished the quick start. It did work. Again, you can do that in Python, but we also have the same SDK. It works basically the same way in Go, TypeScript, PHP, and Java, and a couple of other kind of experimental things that are baking in the background. Similarly, if your favorite language is missing, we'd love to hear about it, and hopefully get it supported in the future. But it's doing its thing. If you go back to Get Dagger Cloud, we can see it's gonna do similar to what it did before, but hopefully at the end we'll see that if it does create a binary, I hope that it's cross compiled. We'll see based on
the current path that's going down. I don't have high hopes.
No, look at this.
It set the variable. Yeah, but I don't know what it's doing in its container.
Those are right.
No, it's gonna work.
Go OS and go.
I believe in it. Now this is all you need, right? Once you have this, you're in business. And again,
but yeah,
with the environment variable,
did some weird stuff.
It was a junior. It's just learning. Like let it learn. Let it cook. Okay, look. With env variable again, these are just built-in functions of the Dagger API. So because we've given it container input, it can use all the functions the container has. So similar.
Can we actually? That's a point I wanted to ask about. So we recently had a PR that I think is in the current version, right, where we scope down a little bit, like some of the types, and on some types, like which functions are available to keep the LLM on happy path, right? That's engaged right here, right? We're seeing that.
It is, yeah. So when you typed in your other shell, when you said container.help and saw all the things you can do with container, we've actually selected which ones of those are reasonably going to be used by an LLM and restricted those, because we found that when you have, I don't remember what the exact number was, but 40 tools compared to 10 tools, they tend to just get lost. For a lot of different models.
The too many tools problem. Yeah,
that's right.
I got the same problem if I open up my little like IKEA box of tools and I know which one to use. Okay, now, all right. Here's the moment. Here's the moment of truth. Here it is.
All right.
So it
I think it's
said
gonna work,
it made curl-clone. It told me about
Yep.
it here, and it's gonna run on M1 processors. I have an M3, so we'll see. Yes, that was a flex.
Training date. Yeah.
Yeah, I got M4, but no big deal.
Oh, okay.
I was gonna say your prompt is different in the Go program, so that's not gonna use the cache.
Oh, you changed it, yeah.
Sorry. Wait. What changed?
Your
prompt or your assignment to the Go program.
Oh no.
This would be a good time for showing the variables that you can assign variables in shell too. So you don't have to like type that whole thing again.
Yeah.
Yeah, assign that as a variable. Yes.
Yeah, so Dagger shell is like a bash-like shell here, so I can use these sorts of things.
Do it.
So now, instead of messing up like this, I can pipe task. Or I can call task in the pipe file and pipe
$sign task.
Oops, yep. Now the problem is I don't actually know if it's gonna have the same name. So I don't know. We'll see. Oops. Yeah, it doesn't like that. There's no. It doesn't exist in this case.
You gotta look
Let's
inside.
pop in and see. Yeah.
Yeah. All right. So source curl-clone. Okay. Oh, it's in source instead of path.
Source. Yeah.
Interesting.
Yeah.
Okay. Well,
that was one of the things that changed when it was getting lost. That's why I was unsure about what was happening.
All right. Well, fair enough. But here I can.
It's okay.
Wait,
yeah.
It was still curl-clone, right?
Yep.
All right. Boom. Okay.
Oh,
so
yeah.
now in theory, if I call curl-clone.
Oh my God.
On Mac OS,
Yeah.
Macintosh OS. Now this is kind of amazing because this was not planned, and I'm happy that it works. And it might not have worked, but it's really cool because I've now built this thing on Linux, and then cross-compiled it, and then ran it on my Mac. And I didn't do any of that. Like the LLM figured out what needed to be done and got it done, which is awesome, I think.
Lev, I want to ask you a favor.
Yeah.
Can you type in $, whatever your thing was called, task? Is that what it's called, right?
Yep.
So hit enter. Okay, it's cached. It's a container. Can you do that again? $task, and then pipe, and tab.
Oh.
I wanted to see what we had available here. So this is showing you what it has available. Interesting. Okay. So it's got two things. So we got Go program, which is the one that we ran to have it Go program for us. And then can you click the completions one? I'm super curious. That's the title.
Yeah, that is the thing.
So it's only showing that one.
Those aren't right. Yeah, I think it messed up with the variable. So it's not sure what it is, right? But if you do container, pipe, and then tab, we get lots of cool things. Or do your
container,
pipe first.
Pipe, tab. Okay. And how many do we get here? I'm just curious. Let's see how many we get. About 1, 2.
Well, it's paginated, so there's more.
I just wanted to see if this was like the short list compared to.
This is the full list. Yeah.
That's the full list, right? I was trying to see if if we could see that short list somewhere within here, if we somehow knew we were in an LLM context.
What do you mean by short list though?
The short, well,
ones
I'm saying like
that are masked
that giant list
LLM.
the container has been abbreviated. Once you hand it to an LLM, we've abbreviated it so that it doesn't get lost. And now it's just trying to see if we could see it somewhere easily.
Yeah. So the main way to do that would be maybe assign a variable to a container, or you already have one task.
Right.
So then go into prompt mode.
Oh, prompt mode. Boom.
And say, what tools do you have?
Oh, we're going direct to the LLM now and letting it see everything we've got.
Oh, interesting.
So it sees a bit of the core API. Maybe ask it to select task or select container, and then what can it do from there?
So in this case, it's actually doing tool calling.
It is.
Doing tool calling to figure out the tools it can call.
Yep.
Yep.
Whoa. Okay, that is a much abbreviated list. Look at that.
Yeah, and notice how the things that it called earlier, like we saw it trying this, we saw it doing this. So that's where all that stuff comes from.
And check out those descriptions. So those are the same things you get as type hints in your IDE. Yep. And that's exactly what the LLM sees when it's looking at these different functions.
Yeah, this is really cool. I actually haven't seen this yet.
Oh, wait.
This is really cool. Yeah.
Oh, man.
Yeah. So,
Solomon got his prototype to work.
Oh, wave him on in. He's in the stream.
You want to come in?
I'm here.
He's at the door.
Special guest star? Okay, hold on a second. Let me.
I feel like I'm hovering over your shoulders. Like
there he is. Nice.
What you guys doing?
Oh, good.
I don't know. It barely works, but it's actually. I don't know. I kind of want to show it to someone. That's mostly why. It's relevant to what you guys are doing.
Yeah, all you gotta do is share your screen, and then we can throw it up there on the stage.
Hey, Lev, I missed the in between, like the thing that you just got to work. Was it like you kind of coded?
I just told agent. I did the same, like make me a curl clone, but then I said make sure it runs on Darwin. So then it was compiled. It was compiled in Linux, but then I ran it on my Mac after exporting the file out.
Oh, nice.
And that worked. Yeah.
And ARM64. So
ARM64.
we've seen it go the other ways too. So that was
to give it
Has it ever tried to make me a PPC version?
We could give it a module that has like cross compile functions ready to go, and say make sure it runs on.
No, but it figured it out. It just
figured it out. It figured it out. Yeah. So that was
Go OS and Go Arch. It was pretty hot. Yeah.
So my thing is very experimental. It's more of a conversation starter, but it's got to do with. I mean, I mentioned it to Kyle because I had to ask a question. I revealed myself a little bit in the Discord, but it's basically this new API that we have for constructing an environment for the LLM. Like binding objects to it so that it can compose all these objects. We made this switch from for those of you who remember a single object, like so many weeks ago, might as well be last century. Like it was less powerful because you could only give the LLM one object with a bunch of functions. So it mapped roughly, the MCP protocol, but we wanted Dagger. We wanted more. We wanted to give any number of objects so the LLM can do composition of them. And so we got that to work. But the API is a little bit more complicated, right? Now you have this, you're basically you're dynamically constructing what looks a lot like a function, within a function, because you're creating this environment and you're defining inputs with types and names and then outputs, and so anyway, that's kind of the preamble to my prototype, but I had this itch that maybe we could have like a sort of a custom SDK where you don't have to write that boilerplate code and somehow it maps directly to an actual Dagger function. You just somehow, if you could somehow describe your agentic function and say, instead of explicitly in having a function with its own arguments that then calls code, where you're basically creating a second level of function dynamically, just make it the same thing. And you already have a way to define typed inputs. It's the arguments to your function. You can only return one value in a Dagger function, so it doesn't map directly to the multiple outputs in the LLM environment, but you could return an object custom made for this function that has one field per output. So then you just return the object with all the fields, So that's what I wanted to experiment with. So let me see. I'll show you what I have.
Oh wow!
Nice. Yeah, that even came up during our live stream, like that analogy of like the M being like a.
Yeah, I mean it's clearly it kind of. So it's a little module that I made called Agent SDK.
All right, let's do it.
And it's on my GitHub. It's really broken, but can you see my screen?
Yeah, we're gonna do it just a second. Let me.
Okay. Wait,
let me pull off Lev's and throw on yours. Here we go.
Okay.
So it's live. This is the address, so you can use it. And I have a little example in there. I will spare you the horrible sight of the code. But I have a little crash test module. So this is a Dagger module, and this is the source code for it. You have a Dagger JSON, and then the SDK would be, blah, 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 agent SDK, but here it's in the same repo, right? And then this is the source code of my agent. So it basically have a little YAML file. Ironic, I know.
Yeah, this is shocking.
And so here, I basically I can configure the model of my agent, and then I give it a list of actions. And each action has a name and description, and it has inputs. And here you can see, okay, well, there's an assignment. This is a description. It's a string. There's a workspace. It's a directory. It's optional. There's a description. And then I also optionally can add instructions. And the idea is, this is shown to the caller, just like any other Dagger function. And the LLM that's supposed to implement it will be given the description, but you can also add additional instructions, like additional prompt, and it's basically going to combine them together to give to the agent, to the LLM, and then same thing with the results. So this is the part where we see if it works. So if I open that module, actually, just for the sake of it, you can do this now. Also, you can do Dagger-M. .com shikes/x for experimental agent SDK examples crash test. So I'm just going to load this in the shell. I think I pushed all the changes. All right, did I push all the changes? Nope. Oh, I guess I pushed my. Oops. Okay, never mind.
Don't run it.
Okay, don't. I think it blocked me from pushing it.
That's good.
Okay, so this will work soon, but not quite this second. If you type this command now, it's going to run an older broken version. So, okay, so it loaded. By the way, notice it's pretty fast.
Yeah.
Because it has less to actually. The slowest part is probably connecting to my Dagger engine because I have bad Wi-Fi. But yeah, I have this little module, and you can see I have Go program. So let me just show side by side here.
Yep.
Maybe not. And if I go, okay, what's in Go program? Let's see, it takes an assignment, an optional workspace, and it returns a crashed, a Go program result. And if I say, okay, what's in the Go program result? It says, well, it has. If you have that result, you can get this, right? The result. I guess the result is kind of productive here, but okay, how about this? Finished. Completed work. Reloading.
Oh, it likes underscores too. It's cool with that.
I guess we'll find out. Go program.
The crash test, right?
Oh yeah, so you can see completed work. I guess it replaces it with an underscore. I don't know. Oh yeah, I guess it does work. Yeah, underscore for the CLI. Anyway, so this is better because this result is very different from the other result, right?
Yep.
Okay, so now if I call Go program, write me. What's another? Because I'm always using curl clone out of habit. What's another good one?
wget clone.
Okay.
Very different.
Okay. Okay, so you can see something's happening.
Are you? Is it going to cloud?
Oh, I guess so. Yeah.
Nice.
Cool. So, Oh, I guess
it says it's done.
Okay.
This is cool because we just went through this. Yeah, so it's cool to see this.
Yeah, but I'm surprised that I'm not seeing the prompt. Oh, I guess it's in here. No? I was expecting. I don't know why the prompt is not in there.
I don't see a human anywhere.
There's no human in the loop.
Yeah, there should be a human. All right, well, it looks like it worked. So, okay, so now I have the results.
Completed work.
So I get completed work.
Directory.
It's only the directory, right? I don't have a container. So, you know, it's there. I did it.
Oh, but you can put it in a container too.
Yeah, you can put that in a container.
Yeah, I can.
With directory, $.
Boom.
Boom. It's got to pull that Golang.
Oh yeah, right.
This is really cool.
Yeah,
what is are you gonna explain what's happening? Like, how is this YAML turning into a thing?
By the power of magic. Well,
YAML
first
back?
so it's when you make, so I wrote a custom SDK, and an SDK is really actually a Dagger SDK is made of two parts. There's a client generator, optional, and then there's a runtime. And in this case, there's no, I don't need a client generator. So the client generator is if the module that you're developing with this SDK itself needs to it has code that might want to call the Dagger API, then the SDK can generate a client to allow that to happen natively. But here, I'm not writing any code in my agent, right? It's just YAML, so I don't need a client generator. And the runtime is basically a custom container, like a custom sandbox that takes the source code of my module, so here, this file, and turns it into, like a mini server that can be loaded into the Dagger engine and serve, like, expose new types, new functions, and execute those functions. So basically, I wrote a runtime that takes this as input, and then like on the fly creates environment when exposes these as Dagger functions, and when these functions are called, it has a hard-coded implementation that does all the same stuff you just showed before. So
yep,
dag.end with input, with output, LLM with prompt loop. It's just that it does it kind of in a hard-coded way. So here, I'll show you the code real quick. Actually, I just want to see that this build. It's not going to build because there's no go.mod. Okay. So
yeah. Well, go out. You can go. We can.
Huh? What?
No.
Oh, yeah, go run it. Okay. Let's do it.
Go run it.
You're go run.
You can go run it.
Oh yeah. Okay. Go run. Go run.
Yes.
Oh, wait. What just happened?
Yes.
Okay. It's promising.
Look at that.
Oh wow.
Fancy.
Hey, it's less noisy. It's less noisy.
I think, yeah.
Wait, hold on. Let me get a real shell here. Okay. Oh, it worked.
Yeah.
Wow.
That's well, awesome. It's the same. It's this. It's still the same LLM. By the way, this is 4.1. So anyway, so okay. Let me show you the code real quick. It's very gnarly code, but normally it only has to be written once, right? So basically the runtime is, I learned a lot, by the way, about developing Dagger runtimes, and got a lot of help from Helder and Tom, just kind of pointing me the way. But yeah, so I have this is a little Go binary. It's got it's 300 lines or so, plus some utilities. And you can see it parses. This is the same structure from that YAML. So it parses that YAML configuration. And then, this is dispatch. This is like for when the engine, let's see, when the engine says, okay, well, you got a function, the client wants Go program. So it just passes a definition of this function call, right? So like this would say, call the function Go program with the arguments, assignment is this, whatever, in Dagger API. By the way, it's very, very cool how this was done. For those who don't know, when the client talks to the Dagger engine, and it says, please call this function. If that function is registered to a custom runtime like mine, that runtime itself, the way it was registered is it was a client first. So as a client, you can say, I'm a client, but also I want to be a server now. So you're registering, you're saying as a client, here are some functions that I can be a server for in the future. And then, so there's this really nice sort of turtles all the way down system where Dagger can kind of is basically completely self-hosted. But anyway, the fun part really is.
And you can't ignore the question at the bottom too, Solomon.
What?
You can't ignore Tony's.
I can't
question.
see.
You can't see it right now.
He can't see that, Jeremy.
Oh yeah, but if there are questions, please tell me.
Oh, he can't see it.
Yeah, you can't. When you're
I'm just seeing my one screen.
Oh, okay.
Yeah, but I can ask it. So Tony asks, is this more or less a module that takes a config file instead of a number of variables?
It's a module that takes a config file. No, it's not a module. It's an SDK that allows you to develop your own agent modules with only a config file instead of writing boilerplate code. So this is not a module that you would call. This is the SDK that we're looking at. The module is this. This is my agent, all of it. And so basically what this means is I can do this. I can actually maybe it makes more sense if I do this.
Is this
create a new example from scratch.
That plus your Dagger JSON, right? You need your Dagger JSON.
Yeah. So here I am in a brand new directory, right? I'm going to Dagger init -- SDK, and usually I would do this. You would do this. Use this module as an SDK, but because I have to sort out not sharing my OpenAI keys, instead I'm just going to point to my local copy.
Yep.
Okay. And now,
new module.
Oh, it doesn't. Yeah, new module. And so now I'll just do this agent.yaml. So I'm now developing a new agent from scratch, right? And I'm just I don't fully remember the syntax, to be honest. So, I'm going to set a module. I'm going to say, you know what, this one I'm going to use 4.0. And, the actions are going to be, I'm just going to say, I don't know. Actually, I can't. Oh, yeah, I guess I can. Joke. Description, tell a joke.
All right, be careful here.
Inputs. No
Does
inputs.
It need any? Does it need any?
No, it doesn't need any. I don't think so. I've never tried
It's
without.
SFW level.
That's so
Name,
simple.
joke. Type. So unfortunately, there's no string output yet. I think Alex just added it. So it's going to be a file. Actually, I'm going to make a directory.
Okay. Jokes.
Yeah, jokes. Tell jokes. Wait. Tell 3 different jokes.
Yes.
There you go. Type directory. Description. A directory containing the jokes. Each joke is in a separate text file. So here, I love the part where you're describing the function, where you're really kind of prompting, right?
Yep.
And I guess that's it. Each joke is in a different language and in a separate text file. Okay. And I think that's it. I think that's all I need. So now I have just developed an agent, an agentic function with one action that's an agentic function. And now I can try to execute it. Oh, the other cool part, the reason Cal was asking, because I was asking about this, and Cal was like, well, maybe since you seem stuck in this gnarly code that at the time did not work, maybe you should just make it a regular module for now to make the point. But the reason I didn't want to is for a really important reason. I wanted the dependencies of this module to be automatically available as tools to the LLM. You know what I'm saying? So for example, here, if I install I don't know how to make that point here, but actually,
you can install the Go program one from the other directory.
Yeah, just that for telling jokes. I don't know how.
Sorry.
I'm just gonna use the hello
Write
one.
a Go program that tells jokes.
Yeah, I was so Tony's asking more questions, and they're similar to mine, which is like it would be fair to call this a YAML SDK, right? Like
No, well,
or
it's
LLMs only.
No, it's
For
not YAML
LLM.
SDK because it's super specialized. It happens to use YAML, but I just couldn't think of a.
Yeah.
It could be
So, but you
JSON.
could have used a different format, right? But it's like
Yes. The point is, no code needs to be written.
a no-code SDK, yes, because he's talking about how this is more or less how he was thinking about creating the Q SDK v2, basically wrap the Go SDK in a config. So there's like a little bit of overlap, I think.
Yeah, but not much, because this is very different, because this does not expose the whole Dagger API. In fact, it exposes almost none of it. It's like
I think Mohammed's got the right term for it. The Dagger one file agent.
Yeah.
Yeah, it's basically an agent SDK is what it is. So okay, let's see.
Yeah, but I think someone could take your agent SDK, extend it to include more types, and then very quickly you end up in a world where you have a YAML SDK, maybe.
Well, for this particular one, it would be very hard to do that.
Because this specifically instruments everything into an environment.
Yeah.
Let me it to an LLM.
Yeah, it's like a blueprint, right? Is that like a good way to look at it? It's like a blueprint for your functions.
Let me show you where most of the work happens in the SDK. We're back to the SDK code for a second.
Yep.
I'm just here for the jokes.
Like the actual here, okay, we're dispatching a function. This is okay, instantiate the LLM and then run it in a loop. So this is where it actually happens, right? Produce an LLM with everything ready, with all the inputs and outputs connected, and then run the loop, get the environment back, and then get the values of the outputs and return that, basically. And the LLM function that's here, this is where most of the LLM stuff, the boilerplate is. I'm basically saying, okay, create an environment, make it privileged so that the LLM can access core your types. Modules, dependencies. Yeah, core types, and also the dependencies, which is the cool part. So you can install a Go module, and then the LLM will have access to it, which I thought was really cool.
That's cool.
And here we're binding the inputs, and there's a lot of boilerplate for that. Binding the outputs.
Oh wait, so you can Dagger install in your Dagger JSON. So your Dagger JSON, you'll have other modules. Oh,
exactly. That's why I wanted to do it as a runtime, because it's basically the same experience that you have in shell mode. So in prompt mode in the command line, you Dagger install a bunch of modules, and then you go to prompt mode, and then you can tell the agent, you do this, do that, and it's using the current dependencies that you just installed. I wanted the equivalent of that, but encapsulated in code, and you can do it, but it's just more work. So I'm trying to be lazy. This is easy mode. And so here you can see I inject a system prompt attached to the environment, of course, and then I say you are blah, and here I give it the name of the agent, which is the name of the module. So here I'm saying it's going to say you are jokes. A helpful assistant, your task is, and here it's going to be the description of the action. So your task is, tell a bunch of jokes. And then I'm saying, I'm injecting all the prompt stuff that, makes it more likely that it'll succeed.
Yeah.
Anyway, that's basically what I do. There's nothing else in here. There's no facility for exposing anything other than prompting an LLM wrapped in a function.
Right.
So it's a purpose-made SDK for that one NVPI that you guys were showing. So anyway, I just want to show jokes. Oh no. Oh yeah, see, this is how I got, this is exactly what happened to me last time. This is how I leaked I almost leaked. Thank you, GitHub, for stopping me. Okay, jokes.
Yeah, the prompt seems to be swallowed up somewhere. Something to look into afterwards.
Yeah, it's weird because I saw it before.
Oh, right, because it's just a system prompt. There's no user prompt.
Oh, interesting.
Oh, system prompts. Okay, that's the problem. Okay.
Yeah.
Well, maybe I'll change that back then.
Is there a specific reason why you chose system prompt there?
It just seemed like that's what it was. I don't know. No strong reason beyond that.
One of the downsides with that today, as far as I know, there can be one system prompt, right? So Dagger has default one that Alex has been working on that tells it kind of how to do Dagger things. And so if you use a system prompt, you're going to blow that away.
I see. Interesting. Yeah, it's good. I'm glad you're able to show this part too.
What is it doing?
It feels very GitHub action-ish, which is kind of interesting.
All right. Well, these are some good. These are high quality jokes. In fact, Jason, you're wearing the wrong shirt. You had the right shirt earlier today.
So it didn't actually return.
It got a Git repo full of jokes. What happened?
I tried to, yeah.
Yeah, I tried to, and it felt that okay. In this case, ideally, I would be able to do my prompt engineering here. Like here, I'll be able to say,
Yeah, it's really funny though. It tried to use the Dagger APIs to come up with those jokes, right?
Yeah.
So that's why it tried to use the Git repo instead of just generating jokes.
Wait, but it has access to containers and all that stuff already out of the box?
Yeah.
Okay.
Yeah, it does. Yeah, that's why it's doing a little too much here. Okay, so here I'm doing some prompt engineering, right? I'm all I did. Let me close this to avoid confusion. I added some instructions for that one.
And we'd love to get some more.
Wait.
From Mohammed, who's he's asking, can we make do then apply, like think, act, observe, then apply? Love to hear Mohammed maybe more about what you'd like to see it do. But I mean, these verbs sound like they're in our wheelhouse. So.
Okay, it's doing it. It's doing it.
All right.
These are some good jokes. I'm not gonna lie.
Okay. Okay, get the joke.
Open the treasure chest. I want to see.
Joke one. Wow,
Okay.
That's awful.
Joke two. I would avoid the sushi if I was you. It's a little fishy.
Wow.
Okay.
All right.
These are
bad.
We got there eventually.
Yeah.
Okay, this is actually
so
this
on
is
that
kind
on
of
that high note, there was a question about are there any code editors like Cursor or Windsurf that use Dagger for running coding agents or joke agents? And that's a great question. I don't know, but they should be. Is the answer.
We were just talking about this, right? Like yesterday. But I mean, I think the short answer is not yet. But like, yeah, to your point, there should be, because it's just a perfect sandbox for achieving all these sorts
but
of
you can over MCP, right? Which is how you do that today. You would expose Dagger to your Windsurf as MCP.
Yeah. You should make a demo about that if you already have one.
Yeah, you can run. So you can run like Dagger -m your module MCP, and that you can put that in the config file of your editor or your desktop client or whatever. And it's a little rocky today. We're like, it's not, we're making it better and better, but it does work. So
I don't know how I feel about this, Solomon. On the one hand, it's amazing. On the other hand, it's YAML. So
I'm open to suggestions.
No, I can't think of how to improve it. I think I think it's perfect.
Maybe if it was JSON.
That's nice.
No, I would be sad if it was JSON. Maybe it should be like a gosh, what is
TOML.
What is it? Yeah, not TOML though. I'm thinking back to like the 90s. Like, what was the good stuff?
Oh, no.
XML.
Tony says Q. Yeah. What if it's just natural language, right?
Q. Yeah. Q.
That's it. Q, and then it'll like go down to YAML, and then it'll be good.
Yeah.
If we had another LLM layer and just have a natural language agent description that turns that into YAML.
Yes.
I love it.
Yeah, I was thinking like the shell syntax today, like it's pretty close too. Like you could just an abbreviated, because right now you can write one of these with an environment and everything in shell with just pipe together. It's like an abbreviated version in shell.
Yeah. Do you think that
shell prompt mode and like terse shell.
Yeah, I was just thinking though. I think do you think the YAML makes the LLM happier because of just how well structured it is? Like, there's no ambiguity, or do you think that doesn't matter? Because if I just put this in a prompt and use some tabs and exclamation points, would it achieve the same goal?
Well, right now the LLM doesn't see the YAML, but we could try that too.
Oh, I see. But the individual pieces of the YAML are turned into first class environment types.
Yeah,
I'm assuming. Yeah. Okay.
Oh, that's pretty good.
Yeah. You want to translate that for us?
It's kind of what you would imagine. No, it's not that funny. I love how committed I am to my little joke module, but it is saving me a little time for simple cases for prompt engineering. Anyway,
yeah,
that's it. That's my. I want to emphasize this is not a new API, and it doesn't change the engine.
I think you pushed the wrong button.
We lost him.
Come back, Solomon.
All right.
No, he dropped off. I think he
I think he'll be back.
He booted himself, but he'll be back.
This feels like a really natural wrapping up point.
It does.
We went through the quick start. We got an agent working through the quick start. We got it working even better by just changing the pipe, like the prompt. And then Solomon came and blew everybody's mind by taking all the work we just did and turning it into a very simple, 12-line YAML file, which was awesome. So I'm actually really excited to check that out, because, I mean, I could see that being the quick start. Like, here, make a YAML file with these instructions, and then extend it from there. Use other libraries, do whatever you got to do. But like the idea that you have this no code agent SDK is actually really compelling in my mind.
Totally. Yeah, I'm thinking there's just fill in the blank. We generate you a file, or there's a drop down with combinations, and pretty soon you've created your own agent and design your own agent, and out pops this, and you run it, and pretty cool.
Jeremy, do you want to talk about the hack night we have coming up too?
Oh yeah, absolutely. So it's a great plug. So on May 14th, we have a Dagger hack night in San Francisco. So if you happen to be around nearby, have access to someone's credit card to buy a plane ticket, whatever, show up. It's going to be amazing. But yeah, just jump in the Dagger Discord, and you'll see in our events, or dagger.io, the webpage, you'll see on the events this coming up. Again, May 14th, we're going to be hacking on agents like we were today, but it's really fun. We did this in London at KubeCon, and we had I don't remember what it was, 150 people or so.
Yeah,
who ate about 200 pizzas, came and then cranked out a dozen and more demos, and it was pretty awesome. But we're going to do something similar in San Francisco. So if you've never done it before, that's awesome. If you're super experienced with agents and some other frameworks, it'd be awesome too. But yeah, we do this thing where we hang out, we eat, we might have some tutorial stuff if you want to jumpstart on any of this, and then dive right into hacking, and then we demo for each other. So it's a really fun time.
Yeah.
Sorry for dropping. I clicked the
welcome
wrong
back.
button.
Yeah, we're just wrapping up though, Solomon. So this is
I know.
To give, what's the next step? What do people do?
Oh yeah, well, we're in the toy building phase for sure. So join the Discord, install the latest version, read the docs, come ask questions. The one thing I find myself repeating a lot, I know you guys too, is there's no stupid questions on the Discord, and everyone there loves beginners. Technically it's our Discord, but I feel like we're kind of guests to the Dagger community in that Discord at this point. So if you ask questions, you're more likely to have someone from the community helping you than a Dagger employee. I guess it depends on the time of day also, but we're all there also. So yeah, I would say that's action number one, is join the Discord and ask questions.
Come on in.
Yeah, follow the quick start. That's brand new, and yeah, I don't know. It's all the stuff you were saying already. We like, building stuff and then showing it to each other, and then every once in a while it's actually useful, but the rest of the time it's just fun.
Do you see, Solomon? I mean, we were just talking about your example. I think it's awesome. Like I can see that becoming the quick start, because for somebody that doesn't necessarily understand Dagger that much, or is just brand new to some of this stuff, it just feels like such a easy, beautiful, nice on ramp. Where like within a few minutes and 10 lines of YAML, you can have a functioning thing. Do you see that becoming like a production, let's call it SDK, or a production tool?
I mean, possibly. I mean, well, the nice thing with this SDK system is the SDKs themselves are modules, so you don't need anyone's permission to start using an SDK. Really, you can make your own SDK. In fact, one lesson from me in making this prototype is this can probably be easier. Like right now, it's still a pretty hardcore. It's like the ultimate challenge, building a real SDK for Dagger. It's pretty hardcore. But a runtime like this is technically it's an SDK, but it's a much smaller one. And it's really with a little bit of polish, it could be pretty accessible to just make your own custom runtimes or modify one. So I'm hoping that as a byproduct of this, and also another project by Tom, he made a Docker compatible SDK that's experimental somewhere. We haven't really advertised it, but so yeah, these can definitely be used in production, regardless of whether we productize them. Whether we productize this as an official SDK, a little too early to tell, but I guess it depends how people like it and if they want to build stuff on it. My first impression is pretty positive. Like it fills a gap.
I'm gonna try to rewrite my QA agent using that framework and see if that just works.
It's the nice thing is, I mean, that's what I love about this bottom-up model, this Lego brick model that we're adopting. I mean, it's the downside is a lot of your first experience with Dagger is probably not going to be as drop-in and polished as more specialized monolithic tools, because it's a bunch of Lego. But the upside is we can add more polished solutions on top over time, and they're always going to be optional. It's a new kit or a new brick. You want to use the new brick, you can use it, but you don't have to. So yeah, I kind of like this one right now. I'm going to play with it also. We'll see.
Yeah, I'm excited. I'm excited to check it out. It also reminds me of just thinking, like in the past, we've always talked about, even our docs, like using Dagger versus extending Dagger. This is such a great way, I think, to just like get your hands there to use it, try it, make something. And then the pathway opens up, and some of the concepts become familiar to where when you do crack open the SDK and start writing your own code, it's not just starting from scratch. You have this foundation already.
Yeah. And what I wanted to say to reassure people, just when I accidentally closed my window before, was that I just wanted to clarify that what I showed is not a modified version of Dagger at all. It's not a dev build. I'm just on regular stable 0.18.3. It's just my little runtime that is homemade. But the way Dagger works, it's honestly so powerful. If you're a power user, if you're like a hardcore systems engineer, this is like a really fun sandbox, because you can extend this engine in very powerful ways without actually rebuilding it. So yeah, that's what I was experimenting with. And it's the same APIs that you guys were showing before. It's the same exact APIs, just with a little extra layer on top.
You can see like a platform team like offering this to their folks to like, oh, you're building agents. We've got all sorts of stuff in here that are, our safeguards, our preferences. Here, what we present to you, fill out the form, and you get an agent. It's I don't know, pretty awesome.
Yeah, it made me kind of wonder, okay, what would happen if we made it 10 times easier to develop these custom runtimes,
Yeah.
would it change how power users actually use Dagger? Would it become more of a commodity thing to do?
Yeah.
In the hierarchy of usage, right? You use the command line, you just use modules that other people wrote for you, and then you graduate to writing your own modules with the SDKs. And then, there's no next step unless you're one of the 10 people in the world who are going to contribute in a big SDK, an official SDK. But maybe there's a third step where you're just sort of eventually you graduate to developing your own runtimes, because it's just another module that's just a module that can run other modules. That's what it is.
Yep.
Awesome.
It's awesome.
All right. To wrap up, the one last question that we have from the audience is: are there any companies using AI agents through Dagger, and can we tell about any? I've heard, and I'll just give my take. We've heard, I think, directly from some users that are using Dagger for, building, testing their code, CI and et cetera use cases, that are now telling us that and next they want to implement some AI features, some LLM type features. And since they're using Dagger for the one, they're looking at the next. I don't know if we have any folks that are on record about this that we can talk about, but
there's tons of people in Discord, in the Containerize Your Agents channel. That's where we all talk about building agents, and lots of people in there building some really cool AI agents with Dagger.
Yeah, we don't have any official case studies or anything like that, but this is all pretty new, and we have a lot of people that are experimenting with this, and we expect over the coming weeks to have more concrete examples and real production use cases.
Absolutely. Cool. And Mohammed is putting a bunch of faith in us here. I like this characterization. Yeah. Very cool. So an extra tool in your toolbox that could, it's maybe going to come to dominate a lot of what we do. All of us do is, making sure that we're taking advantage of the LLM capabilities that are out there. This new primitive is just too cool to ignore. So we'll revisit in another live stream soon, I'm sure, with new stuff. But yeah, I think we're going to call it there, right? Everybody, it was super fun. First one that we've done kind of in this format, this particular format for a minute. But
thanks for letting me crash.
Yeah, thanks, Solomon. That was great.
That's fun.
Now you owe us another awesome demo for next time. So
yeah, that's part of our formula.
It's a format. You have to kind of come in unannounced at a certain point. We'll plan on how to do that exactly. Be super. Right on. All right, everybody. See you next time.
Yeah. Take care.
Bye.